This problem is going to begin our practice. And this problem is as simple as they come, but not easy, right? Simple means it follows the basic rules. There's nothing happening here that goes beyond our techniques we've already discussed. Um, but don't confuse probability with ever being easy. Probability is tough. So what I want you to do, read the problem. When rolling two dice, what is the probability of rolling two even numbers? So again, we're going to make the assumption on every problem we do. Whenever we talk about dice, they are six-sided die and they are fair. Okay. Um, so now, what is the probability of rolling two evens? Now pause the problem and then I will give it a go. All right. What I want you to remember when we do this problem, we're going to say it's actually the probability of rolling two evens is actually two separate problems. We have a numerator and a denominator. Now remember, the numerator is the cardinality of the event, and the denominator is the cardinality of the sample space. And we have already done this before. We know when you're rolling two die, the cardinality of the sample space is 36. So just as a quick reminder, remember it's decisions and choices. First die, I have one decision to make. What and I have six choices. What number is it going to be? Then the second die, same thing. I have one decision, another decision, second decision, and six choices, which gives us a total of 6 times 6, which makes 36. Now, for the event, you always take care of your condition first. So, if I was going to use counting techniques, but that comes later. So for right now, let's just count it up on our hands and our fingers and our toes. Just how many ways are there for me to roll two even numbers? Well, I could roll a 2 and a 2. I could roll a 2 and a 4. I could roll a 2 and a 6. And if that's enough for you to figure out the pattern, you don't have to write anymore. But if you need one more, you say, okay, that would be all the scenarios where my first die, my red die was a 2, and my blue die was a green. Or my blue die was a 2, right? Or however you want to look at these. Remember, it's not first and second. It's the two individual distinguishable dice. Okay, so I got a 2 2, 2 4, 2 6. I could also roll a 4 2, 4 4, 4 6, or a 6 2, 6 4, 6 6. Okay, so there's a total of 9 possibilities. All right, see, not too bad. And so therefore it is 9 out of 36, and 9 goes into 9 one time, 9 goes into 36 four times, so therefore it's 1/4, and there we are. So there's your probability. All right, now let's do another one, slightly different. Now we're doing coins. When flipping three coins, what's the probability of getting three heads? Okay, I want you to walk yourself through the process. Figure out what are the two questions, the numerator and the denominator, and see if you can count them up. All right, give it a go. All right, my turn. Let's see. All right, what's the probability of getting all three heads? All right, I'm going to start with the denominator, the sample space. When flipping three coins, I have three decisions to make. First coin, second coin, third coin. Or remember, it's not really order, it's penny, nickel, dime, whatever they are, distinguishable. Okay, so I have heads or tails for the first one, heads or tails for the second one, heads or tails for the third one. 2 times 2 times 2. That makes a total of 8 different possibilities. Now, the event, getting three heads. How many ways are there for me to get three heads? Well, there's just one way. I have to get heads, heads, heads. The penny has to be a heads, the nickel has to be a heads, the dime has to be a heads. That's it. So therefore, the probability is 1 out of 8. All right, I hope you got that. Now, if you wrote this out and you wrote out the whole list, I'm hoping you aren't going to do that again now that we have 300 coins. Okay, so good luck figuring this one out. See if you figured from the last one to figure out kind of the pattern. And I'll take a shot at it in 1 second. Okay, so now getting 300 heads when flipping 300 coins sounds daunting, but it's not that bad. Because if you realize, all right, I have 300 unique coins, penny, nickel, dime, quarter, half dollar, peso, I don't know, whatever other coins are out there in the world, it doesn't really matter. It's going to be 2 times 2 times 2, so on and so forth. And I'm going to do that 300 times. So that would just be 2 raised to the 300. All right, easy enough. Now, numerator, the event. How many ways are there for me to get all heads? There's one way. They all come up heads. And there's your answer. Do you need to type into your calculator 2 to the 300 and find out what that number is? Probably not. Depends on the context. But More likely than not, this is okay. Now, and depending on your system, if you're using MathAS or WebAssign or whatever it is, um, just go with your class and what they're asking you to do. But that's the big idea. Okay, let's do one more. Okay, in this problem, we're asking us to find when flipping 20 coins, what's the probability of getting exactly two heads? Don't try this problem on your own. Follow me through it. But the point is this is actually what we're going to do in the next section. Okay, so it's just to give you a heads up of why the problems in this section are kind of pointed to be like flipping 300 heads when you're flipping 300 coins or something like that. Because in this problem, if I'm flipping 20 coins, all right, I could get and I want exactly two heads. Well, the first way I could do that is get heads, heads, then tails, 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 and I'm going to need, well, since it's 20 coins, I'm going to need 18 of those, right? So then I could also get heads, tails, heads, tails, 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 right, so on and so forth. So the question is if I keep scooting this along, and every single time scooting I get a heads first, then a heads in the next spot. Well, since there's a total of 19 other coins, not counting the first one. The first one was heads, then there's 19 others. That means I'm going to have 19 possible ways of doing that. Then I could do tails, heads, heads, tails, 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 so on and so forth. Tails, heads, tails, heads, tails, 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 tails. So heads in the second spot, and then heads in the third, or fourth, or fifth, or fifth. So then that will give me 18 possibilities. Or I could get tails, tails, and the first two, and then heads in the third, heads in the fourth, tails going four, so on and so forth. So if you see this pattern, I'm now limiting myself down to 17 different options. So theoretically, we could do this and add up all those numbers. That doesn't sound like fun. So instead, in the next section, what we're going to do, okay, so what we're going to do is say when flipping 20 coins, well, the denominator would still be the same. Two faces for each coin, 20 raised to the 20th. That didn't change. Now, if I want exactly two heads, then just what that means is out of my 20 coins, I need combinations of two. The first and the second, the first and the third, the first and the fourth, or the second and the third, the second and the third, second and the fourth, so on and so forth. So 20 combinations too. And so in the future chapters, we're going to use permutations and combinations, which you already know from the previous chapters. But for now, they're not expecting you to use any of that. So in the previous problems, anything that comes up in this section, just know the ideas are just probabilities, none of the permutations or combinations. All right, hope this helps and gets you going.